Greetings, everyone. Welcome to another episode of The Launch Space. My name is Brian Benz. I'm a cloud advocate at Microsoft. And with me today is Dmitry Soshnikov. We're going to talk about deep learning. Specifically, the title of the session is Jupyter Notebooks, an ideal way to study deep learning with PyTorch on MS Learn. Before we get started, I just want to invite those folks who are on the YouTube developer channel. Welcome. If you want to interact with our speaker today and myself, please go over to aka.ms/learntv, where you can chat and share comments, and we'll be sharing links and things over there as well. So welcome, Dmitry. Welcome to the show, and you want to tell us a little bit about yourself?
Sure. Thank you, Brian. Thanks for inviting me. I am also cloud developer advocate at Microsoft. I work with universities. I'm making sure that universities can take advantage of using our cloud. And I'm also specializing in the AI and ML. Before becoming cloud advocate, I was a software developer engineer for a couple of years. We had the team in Europe who came to big European companies and helped them use AI in their project. So I had some great experience with deep learning hands-on. And even before that, I was an evangelist at Microsoft for quite many years. I think it's my 15th year at Microsoft.
Great. Congratulations on that.
Thank you. So yeah, two things that I like doing. I like technology. I like playing with AI, and I like teaching. So that's why it's my passion to develop some content, some learning content for people to use. And that is something we're going to talk about today.
Yeah, I love myself as well. That's why I was always been drawn to developer advocacy, is my love for learning and sharing. You know, it's great to be able to have this opportunity to do this. So today the show is about deep learning. So I would like to get a little bit of a definition for myself as well as the audience. You know, you hear deep learning, you hear machine learning, you hear artificial intelligence. Machine learning is really just artificial intelligence in Python. All kinds of things, all kinds of jokes. Share a little bit of your knowledge on what exactly is deep learning, and then we can get into the subject as well.
Well, the easiest way to understand deep learning, I think, is to think that it's an advanced kind of machine learning, which allows you to solve very difficult tasks. So machine learning is a pretty broad term. It's when you have the computer and you teach the computer to do certain things by providing data. So that is machine learning. Inside machine learning, there is one specific type of machine learning, which is neural networks, a specific kind of algorithm engineered similar to human brain, in a way. I'm oversimplifying a little bit, but that's the big picture. And then in neural networks are normally layered. And when you have the big neural networks with many layers, that's deep learning. That's why it's called deep, because they are deep. They have many layers. So that's pretty much the picture. And the reason everybody should start getting familiar with deep learning is that nowadays we can see a lot of progress in the field of artificial intelligence, and many problems which were not possible to solve before, like, for example, determining people's emotions based on the picture. Those problems can be solved using deep learning. And more things become possible nowadays. And that's why I think developers should get a good idea of how deep learning works and should be able to apply some of that knowledge in their work.
Awesome. Yeah, no, I actually recently heard about an article I found interesting, which was quantum physics. They set up a deep learning process, algorithm, whatever you want to call it, to define experiments. To identify aspects of quantum physics. And the model actually built and devised experiments that they hadn't thought of, things that were like, oh, that's a good idea. So yeah, it's just an opportunity to take something and put out something that's really deep as well. And I'm interested as well. There's some interesting things going on with deep learning and machine learning and music as well, where you could actually feed a bunch of music into an algorithm and have it produce music as well. That's very cool stuff. It's interesting. There's so many different things you can do with this.
Yeah, that's my favorite part about AI and art, how you can use it to produce art, because AI now becomes pretty powerful. But also you can think about deep learning as the very powerful pattern recognizer. So normally, like if you consider problems like medical image recognition and those kind of things, sometimes a person cannot capture some patterns, and deep learning can. So in fact, what it learns to do from data, it learns to capture certain things from data, and computers are becoming very good at that.
Yeah, better than our brains. I mean, our brains are pretty good at pattern recognition, but then they get distracted, whereas the learning algorithms don't. So it's kind of cool stuff. So today we're going to talk about Jupyter a little bit. It's a well-known technology, but maybe people don't understand what it is. Is it a company? Is it a GitHub project? What exactly is Jupyter and Jupyter Notebooks, and how can you use them?
Well, I think the best thing is to show. So let me start by showing you a small demonstration. So in general, Jupyter is the way to combine code and text. So suppose you want to learn something. Suppose you want to start learning deep learning. Suppose you want to learn something like PyTorch. So PyTorch is one of the two most popular deep learning libraries. There are essentially, if you want to start with deep learning, there are basically two choices: PyTorch or TensorFlow. And nowadays, PyTorch is becoming more popular, so that's probably a very good choice. It's becoming popular in academia, and so you can find a lot of resources on it. But if you want to start learning, you probably would go to the official site. And on the official site, pytorch.org, you would go to documentation, right? So you want to like quick starts. And in the quick start, I'm having problems finding, maybe that's because the screen is too big. Yeah. So you would go to tutorials. In tutorials, there is this thing called Learn the Basics. And if you click on it, you want to start learning PyTorch, you will see that the whole tutorial is built as a combination of text and code. So it tells like what you want to do, and then it shows you some code in Python. Again, some text and some code in Python. That's very convenient way. That's how normally a book would look like. But in the book, you cannot execute the code. In the book, you can only look at it and like try to figure out what it does for yourself. But here on the website, you also cannot run it. But Jupyter is the environment. It's the basically the approach that allows you to have this kind of executable document. You have the document with the cells, and each cell can contain either a text or executable code. Normally, it came from data science, from Python, but nowadays Jupyter Notebooks support many different programming languages. So if you want to use Jupyter on your own computer, but normally what you would do, you would install Python. And once you have Python, here I have, for example, a directory with one Jupyter Notebook file. You would have to start Jupyter Notebook on your machine. So what it does, it starts a Jupyter server with a Python kernel, with a Python environment running inside it, and then it opens the web browser.
Yeah.
And through the web browser, you can interact with this Jupyter. So what you can do, I'll make it a little bit larger. You can go to this document, and you can see that this document contains, it will open in a moment. You can see it contains different cells. Like one cell is text, and this text is written pretty much in Markdown. It supports LaTeX formula, so pretty powerful stuff. And then executable cell. You can press run, and immediately you get the answer. Very convenient way to learn and also to develop, because data scientists, when they need to play with training neural networks, what they normally do, they do some training, then they need to plot graphs, and then they need to see the results. And like if they were using a normal environment like the giant Python file, that would not be convenient. You cannot execute it step by step. But here, it is very good. You can document the code, you can execute it in pieces, and so on. So Jupyter, as you can see, it's a very convenient tool. Many data scientists use it. but installing Python and having this kind of browser environment is not always convenient, because browser environment lacks certain features. Like normally, software developer used to have like GitHub integration, the ability to check in the code immediately from there, some kind of debugging, because here debugging is not great because there is essentially no debugging. So the easier way to use Jupyter Notebooks on your machine would be to use Visual Studio Code. So inside Visual Studio Code, there is Python extension, which does that for you. So once you have the Jupyter Notebook file, you can open it right here inside Visual Studio Code, and it would have exactly the same kind of cells. They are editable. You can run them one by one and get the same results. It starts, in fact, the Jupyter kernel in the background, so you don't have to do anything manually. Everything happens magically behind the scenes. And you also have some magical things here. For example, I will run the small nice example here in PyTorch, which optimizes mathematical function. So what it does, by the way, it's a nice example. We have the function of two variables, x0 and x1, which has the minimum at the point 3 and -2. And we want to find this minimum by using gradient descent. This is kind of similar to the way neural networks are trained.
Right.
And this piece of code does it. So you see it goes step by step until it reaches this minimal point. So back to the point, the Visual Studio Code allows you, for example, to open the variable explorer, so you can see all the values of all variables inside your cells, and that is very convenient. You don't have to add a lot of prints, when you are debugging. And it has many other interesting features, like it has GitHub integration, so I can check in and check out things right here from Visual Studio Code. And what's even more fantastic, you can work on remote machine, because normally, like if you want to do serious machine learning, you would need a machine with GPU, and it's not always that you have this machine at home. So you might be working on a remote virtual machine. And with a remote virtual machine, of course, you can use Jupyter from the browser. That's one of the convenient things, is that you can start Jupyter server on one machine and access it from the other. So one of the approaches would be to start the Jupyter server on the remote machine and go through the browser. But you can also go through Visual Studio Code. So here there is this remote window, and you see you can connect to remote host. You can open like the whole folder on remote machine, and that would look exactly as it is on. You would work on it as though it's a local machine. Visual Studio Code has been engineered in the fantastically beautiful way. It has the small server which works remotely, and then the client part which works on your machine.
I'll add a little bit there in terms of remote. Just a note that you can connect to Windows and Linux remote hosts. You're not limited to Windows. We make a nice interface and everything looks like it's local, which is a feature of remote desktop in Windows. But this is actually bringing that sort of UI to Linux desktops as well. You're still working with a command line and a remote host, but you're working remotely, which is very cool. Hey, I want to back up a little bit as well for those who might not know. So Visual Studio Code is a free open source text editor. And what you're showing right now is an extension that you can add into Visual Studio Code, which is one of the big features of VS Code, is these extensions. And then GitHub is actually built right into the main product. So cool stuff. Thank you.
Right. Yeah. So normally, one of another way to execute Jupyter Notebooks, if they are located in GitHub, there is a technology called GitHub CodeSpaces. So GitHub CodeSpaces essentially allows you to click on the GitHub repository and say, I want to open it inside the executable environment. And what GitHub would do, it would start up the small virtual machine for you, open up the container there, and open the Visual Studio Code environment right in the browser. So you would be able to start editing the code in the rich environment with autocomplete, with debugging immediately right in the browser. And you can also connect, if you have the Visual Studio Code installed on your computer, you can connect to this remotely as well. So fantastic technology. If you are not using Visual Studio Code, you should absolutely immediately install it with the Python extension.
It's very cool. And one of the advantages of that, when you talk about Codespaces, is you can set up pre-configured environments. So you can set up a private GitHub repo or public, and then you can pre-configure a Codespace with all of the, a Codespace template with all of the prerequisites that you need to run your code. including Jupyter Notebooks and PyTorch, anything like that, Python, certain version of Python, for example, and then run that code space with some reasonable assurance that it will always work with your code. So that's kind of cool. And there's a bunch of pre-made templates as well for code spaces too. So you can start with those and customize them. It's pretty cool.
Yeah, absolutely beautiful technology.
Yeah.
So as we've seen that learning anything in such a way, like with Jupyter Notebooks, becomes very convenient because, first of all, you are able to execute all the code inside the tutorial, and also you can change the code and experiment with it right away. So, for example, in this piece of code, if I want to change the function that I will optimize and make it different, I will just change the code, run it, and I will see immediately how the result changes, and that's definitely very convenient.
Hey, so we have a question. Raman was asking if we have any examples of VS Code CodeSpaces and GitHub integration. I'm looking over here because my YouTube's over here. But yes, are you going to show those later, or we can share some of the links as well?
Well, I think yeah. So GitHub integration and the Visual Studio Code. Pretty much that's done through the remote window. So here, there should be, if you install Codespaces extension, you would see open a Codespace. Here it is, Codespaces, and you can say connect to Codespace.
Yeah.
So that's as easy as that. You don't need really anything difficult. Just set up a Codespace on GitHub. I think it's still technology is still in preview, so you might need to apply for it. Yeah. But yeah, that's how it works.
And then when you do that, what's cool is basically you have the same interface that Dmitry's showing right now on Visual Studio Code. So if you go up to the GitHub link up there, Dmitry, you can show GitHub integration. It'll be basically the same.
Yeah, so the way Codespaces work is that you have this kind of code button. And if you have the access to Codespaces, you have this open with Codespaces. You can say, I want to open this in the new Codespace. Yeah. And that's how it will work. Yeah, it will create the Codespace view.
Yeah, it takes a while to spin up sometimes. So especially when we're doing presentations, it's always, I think it has a trigger to make it slower. But anyway, but if you go back to VS Code, I can show Raman. If you go up to the GitHub on the left, the third one down, the GitHub integration, next one up.
Yeah, this one.
No,
not this one.
No, it's the
this one.
There you go. Yeah, sorry, I'm pointing. Hate doing this. This one's not set up yet, but this is basically where you would integrate, and there's a push, there's a pull, there's a sync, which is push and pull. Everything happens the same exact way in Codespace. So when you actually change things in Codespace, you actually have to sync. You have to push and pull with your original repo, because you're working on a container. You're not really technically in GitHub. You're in a container that's pulled down the GitHub instance at that moment, and then you have to basically commit back to the GitHub repo after that. So that's hopefully an overview for Raman for GitHub in general. So yeah.
Yeah, but let's not go too deep there, because our topic today is learning PyTorch. So I will close Visual Studio Code so that we don't have the temptation to come back to it, because it's just so great. And
absolutely. I'll share some links for integrating with GitHub a bit later. So yeah, we'll get back to PyTorch and our deep learning. Yes, thank you.
Yeah. So let me continue a little bit with this quick start tutorial on the PyTorch website. So this tutorial, we also helped to co-author it together with developer advocates at PyTorch, because what we noticed is that originally PyTorch had a really great tutorial for data scientists. They explained a lot of details. They went into details on how to do automatic differentiations, how to handle tensors, and so on. But software developers might not need to go that deep. Software developers, they normally want a solution fast, right? So you want to come and to be able to copy some code and make it work for your problem. So that's why this quick start tutorial is structured in such a way that you have on the first page, on the quick start page, you have the complete solution, load the data, then define neural network here, then train it, save the model, load the model, you get your neural network model working fast. You can just copy the code from here, and basically that's it. But if you want to learn like why are you writing this code and what different constructions mean, each section has the deeper dive. So like working with data, you can click on the link and go and learn more about what all those things mean. And then the same tutorial also goes like step by step: tensors, data sets, working with data, defining model, and so on. But this is, as I mentioned, this is non-executable content. If you want to run it, the first thing you can see is run in Microsoft Learn. So you can click here and you will switch to the PyTorch learning path, which is available on Microsoft Learn, which is called PyTorch Fundamentals. So this PyTorch Fundamentals learning path consists of different modules. And the first module, like this one, Introduction to PyTorch, you can see that all the sections correspond to the sections on PyTorch website. So it's essentially the same tutorial, but in the executable format, in the working Jupyter Notebooks. And in fact, this was the first module on Microsoft Learn to use Jupyter Notebooks, because before Microsoft Learn, like if you wanted to run some kind of code, you had to manually like open the sandbox and like set things up and do something there. Now, if you go, for example, to the first section here, for example, about tensors, you can see that the first thing it offers you to do is to create the sandbox. So here it says this module requires a sandbox, and if you activate the sandbox, you would be able to execute all code here. Like
Cool.
Click on the cell, and that is exactly the same Jupyter Notebook environment as you have seen in Visual Studio Code. It's a little bit customized, like it looks slightly different because it doesn't have a lot of those details which are useful for debugging, because this code is supposedly like should work. You should not need to debug it a lot. So it looks more like the piece of sample code in the book. But then you can like execute cells and see what the code does. And what's really great is that this environment is GPU enabled. So for the beginner tutorial, that may be not too important, but once you start training more complicated neural networks, that becomes essential, because with GPU, everything is just several times faster. So you don't need to have the powerful machine to start your deep learning experience. You can just use this sandbox environment in Microsoft Learn. Of course, I mean it's targeted for learning, so it's available for you only for a certain period of time, and then you need to activate it again so that you cannot use it like for your commercial development, definitely. But for learning, that's great.
You can yeah, I was going to joke around and say, I'm not sure how much PyTorch is debugged versus how much it's just copied from Stack Overflow anyway. So this is a great way. I mean, runtime is really important, and that's really the advantage of using our Learn module versus the PyTorch tutorial, right? Is we've gone through the effort of integrating Azure tenant and setting up the notebooks for you to use.
Yeah. So this PyTorch tutorial on Microsoft Learn, it's structured a little bit differently. So here we don't start with this quick start which has all the code. We start like from the beginning, because that's it's slightly different approach to learning. We suppose that people come here without a lot of knowledge of deep learning, unlike people who go to PyTorch website, because people who go to PyTorch website, they are likely already data scientists. Like there are a lot of people who are using TensorFlow and who wants to switch to PyTorch, or they just need to do a project with PyTorch. So they will come and they will understand the code. They don't need a lot of explanations. But for the beginner learner, it's still good to start with the beginning. So here we introduce like things like tensors first, then how to load the data, how to transform the data. And at the end, we reach the same, like, which is called full model building process. It's the same code which contains all those things in one go, like in one piece of code. And this is the like real example. You take images and you classify images, like images of clothing. There is a data set called Fashionmanist, which contains like small pictures of different types of clothing, like shirts, like boots, trousers,
hat.
trousers, hats. They are small, 28 by 28 pixels, but still it's the problem which is very close to real world problems. And it shows you how to do the complete classification, with defining neural network to saving and using the model. However, this module doesn't go deeper into explaining why a neural network looks like this, what are different building blocks. It just introduces you the framework.
Mhm.
And that's very good for the start. But if you want to continue, there are 3 more modules. So that's why it's called learning path, because it starts with this introduction to PyTorch, and then it continues with the separate modules on computer vision, natural language processing, and audio classification. Because computer vision and natural language processing are 2 really big areas of artificial intelligence which are very often used in practice. There are a lot of computer vision problems.
So Azure Computer Vision is just one of the family of artificial intelligence, machine learning tools that we have as part of our offerings on Azure. And these are services that run on Azure, and they actually have predefined data sets that it helps model things, right? So you have your own model, which is you provide those pictures you mentioned of different pieces of clothing, but then Azure adds that to its own recognition of other standardized things that they have pre-built. There's several modules and several models that they have for retail, for different purposes. And you can actually apply those and use them as well.
Right. Yeah. So in practice, if you happen to have this computer vision problem like image classification, the first thing you would probably do, you would go to use the Azure service custom vision. As you mentioned, you can just upload images and it will train the model for you. What it does behind the scenes, it trains the machine learning model, not from scratch, but using the pre-built neural networks. But it hides all the complicated machinery behind the scenes. This can give you quite good accuracy, but if your images are not typical, like for example, if you have medical imaging does not work well on top of normal neural networks which are pre-trained on images of cats and dogs, for example. So that's why for very specific areas you would still need to train your own neural networks, and this module PyTorch fundamentals shows you how this can be done. Well, at least it shows you the beginning of this path. Let's look, in fact, inside this first module on computer vision to understand what we are talking about here. So here, first of all, we start talking about how images are represented inside PyTorch. So normally, when you deal with neural networks, neural network it's a mathematical model which takes as an input a series of numbers like the certain vector and produces a vector as an output. But this vector can have different forms. Like, for example, if it's an image, it's not a vector, it's kind of multidimensional matrix. So deep learning operates on so-called tensors. Tensor is this kind of data structure which is multidimensional matrix. And the main thing that PyTorch does, it does very fast operations with those tensors. Like it can multiply them, it can do some more clever things like automatically differentiate all expressions and so on. That helps training neural networks. So first of all, we are talking about different problems that computer vision can help solve. In addition to object classification, there is also object detection when you need to detect where the object is in the picture, and segmentation, which is separating object from the background. But we start with talking how do you represent images at all? And image, you can imagine that it's the two-dimensional array of numbers with one more dimension for colors, because if it's color, it has 3 planes, R, G, and B. So in fact, it's a tensor of certain size. So we start here in computer vision module, we deal with the data set of handwritten digits. Those images are black and white, so that's why it's just two-dimensional tensor. And we use the data set called MNIST. It's a well-known data set among data scientists. And it looks like this. Those are the sample digits which are there. And our goal, the whole module more or less concentrates on the problem of image classification of those handwritten digits. At the end, we start more complicated things like cats and versus dogs classification, which is pretty much very similar to real life problem. And here we first discuss like how those images are represented, and then we use the simplest neural network, which is called like dense neural network perceptron, the first simplest architecture, which it was used to do image classification. So it looks like this. We take the pixels as input, and then we have like one or several layers of neurons. And we discuss here how this network can be defined, the simplest way how to define it in PyTorch, and then how to train it. So training in PyTorch is kind of not very easy process because you need to write a piece of code like this. And because we need to use this training many times afterwards, we take this into a separate library. So each time you open the new unit, it starts with importing this PyTorch CV. PyTorch CV is our own like small file with all the handy functions like training function, loading the data, so that we don't have to repeat this code in every notebook that we use. And you see here there is also a small hack. We download this file from GitHub, in fact, so that it's to make sure that it's available to you as the Python module. So that's the first thing. We use the very simple neural network architecture, and then we switch to the heart of this computer vision, so-called convolutional neural networks. And convolutional neural networks, they are very clever because they look for patterns pretty much in the same way as people do. So for example, when we recognize digits, we might want to look like for horizontal and vertical like lines. Because like, for example, 1 is the vertical line. When you have 4, it has like few vertical lines, several horizontal lines. And to actually separate those lines from the image, we use so-called convolution. Convolution is a filter. We go for each pixel, we compute the average of pixels around it. We add them together using the certain weight matrix, and we achieve different results. So for example, this is called vertical filter. And you can see that after applying this filter to numbers, all the vertical lines, they are highlighted. All horizontal lines essentially disappear. The same goes for horizontal filter. Horizontal lines are highlighted, vertical lines disappear. So if we apply a lot of different filters, we can expect to kind of find patterns in our image. So convolutional neural network is a clever neural network which trains different filters. It learns like which filters it needs. We don't say like do vertical, horizontal, and like it figures it out by itself. But it uses this machinery of finding patterns. So we discuss how those networks work, and you can see with image recognition, it achieves like pretty high accuracy, 97.6% of accuracy when recognizing digits from 1 of 10 classes.
Yeah,
which is pretty good. And you can see what are the filters that the network learned. There are kind of they don't always make sense, but sometimes they kind of do. Yeah, not to us exactly. Artificial intelligence is not always clever. And then we can by using those kind of pattern recognition in several layers, the lowest level will look for those kind of small patterns in the image, and then the higher level would build more complex patterns from the low level ones, and that's how we actually recognize a cat on the picture. It is being constructed from smaller patterns using several layers in the hierarchy.
This is what I was mentioning earlier about we have a pre-made, Azure and other machine learning providers have their own models and bases. And if it's a number you're looking for, you're going to be able to compare with that huge database. And that's what they mean by learning. This huge database says within a certain amount of accuracy, this is a number 9 or a 3. And I remember my early days with machine learning. I was pretty impressed. I did one of the demos I did a couple of years ago at a session was pictures of hammers. And one of the hammers had a yellow handle. And so you run this through the model first. And because you have a limited model, it tells you for the yellow handled one, this is within 90%. I'm pretty sure it's a banana. And then you run it through a few more times and you identify the other hammers. And then it comes back and says, oh yeah, 75%, I'm sure this is a hammer now. and not a banana. So yeah, this is exactly how machine learning works. It's just, and that's why, that's why for those of you who use mobile devices and things like that, image recognition and speech recognition is so much, it gets better and better all the time, and language translation and things like that, just because the base gets better, so yeah.
And you need to be very careful with the data that you provide to the network, because if you never showed it the hammer with the yellow handle, it would probably still think it's a banana. But then if you provide the hammer and the banana, it will understand, okay, it's not the color that's important, it's the shape of the the shape of the whole object. So it need to have some carefully selected examples, and there is a lot of interesting discussions around that, like how to construct data sets so that they are not biased, they are complete, and so on.
Yes, absolutely.
Yeah, and here in this module, we go to even more complicated data sets. So we train the model to recognize those kind of images. This data set is called CFAR10, 10 different object classes with the images of high resolution. I think it's 32 by 32. Well, not too high resolution. Sometimes it's difficult even for a human being to recognize what's there. But that is the problem which can be trained on a GPU in a reasonable amount of time. Like you would still have to sit and wait for 5 minutes before it's trained. But this is like quite feasible. Big neural networks, they are trained for much longer times. Like if you want state-of-the-art technology, which Microsoft uses inside inside custom vision, that is being trained like for weeks on very powerful computers. But here it's a kind of small toy example, but still very close to real life problem. And this architecture, it's pretty simple, like several layers, and you get the accuracy of something like I don't know what is it. It's only 3 epochs. You get the accuracy of 52%, but this is just the beginning. Like 3 epochs is like 3 minutes approximately. And then we also go into more complicated real life examples of cats and dogs. And for cats and dogs, we use pre-trained networks. This is so-called transfer learning. And this is exactly what customvision.ai does. It has the pre-trained network. So here we talk about how you can load the pre-trained network, how you can run this pre-trained network on cats and dogs data set. We take the image of we take the cats versus dogs data set from Microsoft, and then that's how it looks like: a lot of cats, a lot of dogs. And we use the simplest pre-trained model called VGG16. We apply it to the image, and we get the result. For a cat, it pretty much classifies that it's a cat. And then we discuss how you can build your own classifier on top of that. And this is called transfer learning. So like what does the classifier actually do? How it extracts different features from the image. That's how the features look like. That might not tell a lot to you, but if you read a little bit more detail, in more detail, it will explain what it actually is and what's the meaning of those images. So this is called transfer learning. This is, by the way, the architecture of VGG16, which is very simple, like it's maybe 8 or 10 years old network. So that's why it's not extremely complicated, because modern networks, they consist of like 200, 300, 500,000 layers. This one is only like 16 or 18 layers. We show different ways to train the network. And finally, the last module, we discuss how to use it in mobile devices. There is a small network called MobileNet, which is like significantly smaller than big networks. It can be used in environments, in mobile environments. It gives slightly lower accuracy, but still not too low. Like it's still good enough for many of the tasks. And that's the overall way deep learning works. When you increase the capacity of the model like 10 times, you get slight increase in accuracy, because the huge increase in accuracy you get when you just start using deep learning. Even the small network with 16 layers can normally give you a pretty good result.
Sweet. You mentioned natural language processing as well. It's interesting when I think about natural language processing. I'm old enough to remember back in the days when natural language processing was related to DBase and Clipper and FoxPro. Those are database technologies, kids, and it was something very different back then. But the name and the technology has sort of been taken over for this. So the idea behind natural language processing before was, instead of using SQL or some sort of oblique way to do queries on data, you would have more human language that would actually speak to it. So this is similar, but now it's really about actual languages and, you know, translation and text recognition and things like that. It's pretty cool stuff.
Yeah, the main difference here is that when we talk about the traditional technologies, they use semantic parsing. So like you can define the syntax of English language somehow formally as a number of rules, and correct English sentence would be correctly parsed. But with incorrect sentence, the program would not know what to do because it does not recognize where are different parts of the sentence.
Right.
So that's why the neural networks applied to natural language processing, they are much more flexible. Like they don't need to have the precise structure of the language. And that's hugely important nowadays because people do not write incorrect sentences on Twitter, right? They just write something which resembles the natural language. And neural networks can handle that. So this modular natural language processing, it focuses mainly on one problem of text classification, is when you have, for example, news, and you need to classify news into several categories, like news related to sports, to politics, and so on. And there is a data set for that, which is called AG News. So the first thing that we do, we talk about how we can represent those texts as tensors. And this is the data set, like AG News. It contains news of 4 types: world news, sports, business, and science and technology. And our goal is to classify the text into those 4 categories. Of course, like the simplest thing you can think about is using kind of keywords, because when you talk about sports, you say things like football. When you talk about science and technology, you use words like, you don't know, computers and so on. But that's not the best way to do it, because sometimes, for example, you can be talking about science and still mention football. So, for example, scientists found that football players, they are more healthy on average than average people. That's not true, probably, but suppose there is a text like that. So it needs some kind of more clever mechanics. But the simplest approach would be like to somehow estimate the proportion of words. And that's the first thing.
European football players are probably healthy, and the American ones, I'm not so sure. So, yeah.
Americans would say soccer, yeah. Yeah.
Sorry to interrupt.
Sure. Yeah. So, and that's where machine learning comes in. We would not program computer to do things. We will teach computer based on the data set. And the simplest way would be to convert words into kind of statistical information, like how many times each word appeared in the text. And that's the simplest model called bag of words, which is pretty much like the word frequency. And when we train our model on that, we discuss how this can be done. We get pretty good accuracy. In fact, that's the training loop, which is similar to the one on images. We get 86% of classification accuracy, which is like pretty nice. But then there are more clever things you can do. You can, for example, instead of words, you can count pairs of words, which are called bigrams. And that is more accurate, because sometimes 2 words together, they mean something different, you know, like there could be the stable like pair of words, the special term, which would mean something different, and we need to consider it separately from those 2 words themselves. So you can use bigrams, trigrams, but that makes the vocabulary much larger. So you have this problem that, for example, in the text, there are normally like several 100,000 words, maybe not 100, but at least tens of thousands of words. In this news data set, there is something like 80,000 different words. And if you want to train a neural network on those kind of input vectors, each word would be 80,000 vector, which is like a huge vector. PyTorch can handle that somehow, but not very good. So the first thing that comes in mind is how you condense those vectors into smaller vectors, which are called word embeddings. So the next thing that we do, we learn how to convert words into smaller vectors, like vectors of size 100, of size 300, which would convey the meaning of words. And that can be done in very clever ways. There is a thing called word-to-vec, which we discuss here. And this word-to-vec is extremely clever thing to do. Because, for example, you can say, what are the words which are close to the word neural? And it will tell neuronal, neurons, cortical, synaptic, and so on. And those words, they correspond to very similar vectors. You know, this word-to-vec model is trained in such a way that similar words end up as similar vectors. This is kind of projection of natural language into the space of numbers, like into mathematical space, which looks like magic because you can do things like this. For example, you can say, I want to find the vector which corresponds to a king, and then I subtract the vector which corresponds to man and add a vector which corresponds to woman. And guess what I will get? I will get queen. And that's indeed what happens. You see, just by operating on vectors, you operate on the meaning of words. This is kind of magical. That's the thing that we discuss here.
I was going to say as well, you know, anyone who's used autocorrect has seen this in action in maybe some unexpected ways as well. But yeah, this is cool stuff.
That is more clever than autocorrect, though, because autocorrect compares the distance between like how the word is written, but here you would have the words like cortical and synaptic, which would be very similar, which would be close to each other, even though they are different words. We compare meaning, and that is really cool thing. Here we use pre-trained.
I was going to say the constraint with autocorrect, of course, is it's in real time. So, yeah, that's always a challenge too. So, yeah.
Right. And then, so this is like the first thing we can do. We can try to operate on those embeddings because they represent kind of meaning of words, but they do not capture the sequence of words, just the overall meaning. So if you mix the words in different order, the meaning would not change, which is not true, because if you put like not in the different places in the sentence, that would affect the meaning a lot. So that's why you need special neural network models which capture the sequence, which are recurrent neural networks. And we discuss here recurrent neural networks, and we discuss how you can use them for text generation, because neural networks cannot not only be used like for distinguishing which is like text for classifying text. It can also be used for generating new text. And there are in fact different ways that neural networks can be used. For example, translation from one language to another works like that. You first like take one sentence, convert it to a certain vector, and then this vector is used to generate the translation in a different language. That is something which is pictured here. So we train the network here to generate text from letters. So, for example, when you start training it with the word hello, the network would predict next letter for each letter. And it would start generating things like this one. You see, at the beginning, it starts with some nonsense, and then it would start generating meaningful text. Not too meaningful, but then the more you train, the more meaningful the text becomes. That is quite interesting. You can teach the computer to generate fairy tales or news documents. But that technology, like recurrent neural networks, it's pretty old. And nowadays, in the last maybe 2 years, the state-of-the-art technology is called transformers. So finally, we discussed transformers here, not in great detail because that's the complicated architecture. But we briefly discuss it, and we show you how to solve this text classification problem using the state-of-the-art transformer called BERT, pre-trained BERT model. And at the end, we achieved the accuracy of something like 92% on our news dataset, which is higher than we initially achieved using simple models. So you can see how more complicated models allow you to solve problems in a better way. So that is for natural language. We reach pretty much like not maybe state of the art of 2021, but maybe state of the art of 2018. And of course, I mean, if you want to stay completely up to date, then you need to like read scientific papers, and after completing this module, you will be able to at least start understanding the terminology.
So we have 2 questions. Thank you. This is awesome so far. So we've covered computer vision, we've covered NLP. For those of you who are interested in interacting with us, please go to aka.ms/learntv. We'll take your questions over there. And we've got about another 11 minutes or so. We've got a couple of questions to the audience, which is, can you recommend a website that is like a catalog of deep learning topologies? I think you mean sort of models. And Jose Silva, he mentioned that there's a site that he's seen. And then we have another question about, just a path on the MS Learn website that combines a lot of these modules as well. So
I will start with the second one with Microsoft Learn. So up to now, the Microsoft Learn, we have this PyTorch fundamentals learning path, which leads you through all the introductory material. And after that, you pretty much have different options. You can go, for example, to go deeper, to deeper your knowledge. You can go to massive online courses like Coursera. You can, that is if you want to learn more about deep learning as such. Or if you want to know how you train your big models on Azure, you can go to the modules dedicated to Azure machine learning, because there are a lot of modules dedicated to how to use PyTorch inside Azure to train your models efficiently. Because here we do not mention that at all. But in real life, for example, you do not always know what would be the best size of vocabulary to use, what would be the number of neurons in a certain layer which would give you optimal results. And for that, you would need to train models several times. You would need to set up the training pipeline, which would do hyperparameter optimization. And all that can be done using Azure Machine Learning in a much more systematic way than if you are just training in the notebook. And that is the subject of different modules in Microsoft Learn. But all the introductory materials on deep learning is inside this PyTorch learning path.
Cool. And in terms of the site for sharing, I think we'll maybe look up for something in the link. Somebody's mentioning modelzoo.co, but we'll follow up with that at the end.
Yeah. Let me comment briefly on ModelZoo. So ModelZoo is the terminology where you have the catalog of pre-trained networks. In terms of architectures, I think if you start going deeper into the subject, there are certain traditional architectures, like for object detection, for instance segmentation, and I think you just need to continue learning to get because this learning path is just the beginning, it's not the end. And you can learning more how different computer vision tasks can be solved, it will unleash a lot of interesting things for you, which are still there to learn. ModelZoo is a good term to search for, because there are different places where you can find pre-trained models. So that's definitely a good advice.
Cool. And Raman was asking, are there any packages or services available for students for free on Azure? I would suggest, I believe that students can get free Azure. I'll have to share a link later. I'm not sure what the link is, but if you just search on, Azure students free, you're probably going to find something there. I know you can just get a regular free trial, which is most of the things in there are free beyond the initial 30-day period as well. There we go. aka.ms/az4stud. So Azure for Stud. So aka.ms/az4stud. I'll put that in the links on the show page that we have. And by the way, all of the things that we're sharing today in the links, you can find at aka.ms/LearnTV Jupyter. I got that wrong. aka.ms/TheLaunchSpaceJupyter. Those will be available. There it is on the page. aka.ms/TheLaunchSpaceJupyter. I'll share that in the links as well. But you can find all of the links that we mentioned here. I'll be adding them as they come up here right after the show as well. So
yeah, just a short comment on Azure for Students. If you are a student, you would need to verify that using your email account from the university. And if that email account is recognized, you would be able to get for 1 year $100 plus a lot of free services. And definitely that's good to get you started. If you are not there, if your university is somehow not recognized, another good way would be to go for GitHub Learning Pack. Not Learning Pack, GitHub Student Developer Pack it's called. So GitHub Student Developer Pack is a collection of different services from different vendors, like including Microsoft and Amazon and so on. And you can verify your student status by providing some kind of scan of a document there. It will take longer, but you can still do that, and it would give you a lot of services for free. So one of those two options should definitely work for you if you are a student.
Yes, absolutely. And I put, if you go to aka.ms/learntv, you'll see the posts that I put for the student link and the show page that we have here as well. So those are there. And do you want to talk a little bit about audio? We haven't covered audio yet. So we talked about natural language processing as well, but we didn't talk about when you're working with audio versus text.
Right. So the final module which we have here in this learning path is audio classification, introduction to audio classification. And that is kind of not very traditional thing to talk about because like audio is often somehow missed a little bit because it's considered to be like more complicated thing maybe. But in fact, it's very useful that we have this module here because we discuss an interesting way how you can turn audio into pictures and then apply image classification on top of that. And that starts with discussing how audio signals in general look. So we use the data set here which contain different commands. So you can see there is a data set which contains commands like backward, yes, no, visual, wow, and so on. And we solve very simple problem of classifying yes versus no. So you can see how this yes and no look, and you can listen to that right inside the Jupyter Notebook.
No.
So we have a lot of samples like that, and what we do first, we turn them into so-called spectrograms because audio look very different in the frequency domain. So when you start speaking, you produce different frequencies, and this pattern of frequencies determines what you say. And you can this spectrogram might look if you try to draw it, it would look somehow. Just let me show you. This is the waveform, and below is the spectrogram. This is the spectrogram. For each command, it would look slightly different. So what we can take this. What we can do, we can take this image and use this image with image classification like we did before, and that would give us the way to recognize between different commands. So I think that is quite short overview of the audio module, but you are definitely encouraged to have a look at it because it like goes step by step into how you convert sound into spectrogram, how you train the network on spectrograms to get the good result. And I think you get something like 90% accuracy, more than 90% accuracy on those two commands recognition. Cool,
great. That's wonderful. So Raman had a question. He was suggesting that next time we talk about TensorFlow, similar things, but with TensorFlow, I think we do have a learning path for that. TensorFlow's been around for a lot longer, but the cool kids are using PyTorch. So, you know, we want to shoot PyTorch today. So
I don't think we have the TensorFlow yet, but we might. So at some point, we definitely should talk about that. And one more thing I wanted to suggest is that PyTorch, it contains good beginner material, but it also contains a lot of code samples for more complicated things, like how to train word embeddings, how to do like very advanced things. So after learning this learning path, you might want to go back to PyTorch website and look for some samples there, because samples at PyTorch website are also very good.
Yes, it's very cool. It's wonderful stuff. I've just got a couple minutes left. Let's see if we have any more questions. Yeah, so I know just getting back to TensorFlow real quick, I know we've done some things before. Some of the folks that we've worked with in the past, this would be like 2 years ago, have done some TensorFlow learning paths and things. I'll dig them up and I'll put them in the links. So all the links that'll be in the show today are at aka.ms/the launch space Jupyter. You can find them there, and I'll add them as well. Do you want to talk about what we're looking at here?
Yeah, I've just opened one of the examples at the PyTorch website, and this is called reinforcement learning. We are teaching this model to balance the pole automatically. So it's a kind of working model when you have this pole and you can move it left and right, and you need to balance it. So the model gets the values of speed and like velocity and the position of the pole, and then it automatically figures out like how to balance it, which commands you need to do in order to keep it stable after a lot of experiments.
Great. Okay. Well, we're going to leave it there. That's the show for today. Thank you very much, Dmitry. That's wonderful. As I mentioned before, aka.ms/the launch space Jupyter is where all of the links and details will be today. And this recording will be up on YouTube and Learn TV shortly as well. So thank you very much, Dmitry. It was great to see you.
Brian.
Thank you. I know you're over in Eastern Europe. Thank you for staying up very late and much appreciated.
Thank you.